See how we've done this, how many times we still.
Oh, I think we're good.
It says it's waiting.
I see me there.
How many times?
Nope, we're there. We're alive.
Okay. Oh, cool. Well, nice to see everybody this Friday. It's a little bit gloomy here in San Francisco. Oh, that's sorry. Good morning, everybody. Nice to see everybody. How's everyone feeling today?
It's nice here on the East Coast. It's very cool and crisp and Halloween style weather. We had Northern Lights last night. Very nice here. Very nice.
And you know what's cool about those pictures that you shared of the Northern Lights? They're the same color as all the Zillus colors.
Yeah, I
Like,
know. I did that for Milvis.
oh, thank you.
Those are the
Thank you
Milvis
so
lights.
much.
Yeah.
So today we have a very special guest, one of our new team members, Stefan Webb. So welcome, Stefan.
Thanks so much, Chris.
So before we get right into it, I have to ask Tim, what in the world is this outfit that you've got on?
I don't know. It may be related to the season. It may be related to my current project, which is taking on epic proportions. Once I realized how large it was, let's just say Milvis can store anything unstructured. So we may be storing some things that we capture in the field in one of my traps. So we'll see.
So what does it
I'm
say on
building
your
the
arm?
trap, and it's got to have a Raspberry Pi in it, and there's
Of
cameras,
course, of
and
course.
I need clip and splayed and a lot of stuff. But it'll be fun.
Yeah, and what's on the side of your shirt? We see a patch on the
So,
side too.
Ghostbusters.
Oh, did it fall off? No, there we go.
Ah, there we go.
That might be a giveaway. And I'm to build my schema. This is my where I got my schema from.
Nice.
Surprisingly, there's a lot of attributes. So I've got a lot of scalars. I've got 4 vector fields. Building the schema took a while. I mean, there's
Oh, so it's not ad hoc. You're really actually thinking about this
no, I'm
ahead of
building it. I've been building it. It's been, how do I partition the data? And I'm doing it on Ghost class, and it's substantial. There's probably 6 articles here because there's an app, there's a collection app on a Raspberry Pi. There's a bulk loader because I realized I gotta to detect a ghost, I gotta know what they look like. So I'm loading up some standard ghosts into my collection, and then
Oh,
hear them before I let you upload your ghost. I don't want to
oh,
store anything. I mean, I don't want to store cat pictures in the ghost database. That doesn't make any sense. I mean, why would you do
oh, well, why
But
not?
maybe a black cat? I don't know. It's not a Halloween database.
But maybe there's like some ghosts that are cats. So then you have the best of both worlds.
Yeah, I'm probably gonna need one of our data scientists to train a detection model for various Halloween entities, specters and black cats and things that show up like decorations, but we don't need to capture those.
So Stefan, just so you know, Tim just finished a bathroom remodel.
Nice.
And then he got a little bit bored because there was no project, so he wanted to get into the Halloween project. But his wife made him promise that he couldn't start that one until October 1st. So he's
Which was
now.
painful. Being in an old Victorian, there's a lot of creaks and things going on, and I live in Halloween Town, so decorations here are substantial. We closed the historic district for Halloween, so the
Yep.
kids can safely walk down the street. If the police block off all the roads, we're serious about that time here.
Well, I think you need to because you got all those like ghosts that are, lurking about.
Yeah, who are you gonna call, man? Milvis, obviously.
So, Stefan, why don't you start by telling us a little bit about who you are? What's your background?
Yeah, sure. Yeah, thanks, Chris. So I grew up, so I'm Australian. I grew up in Canberra, which not everyone knows it's the capital city of Australia. And so grew up in Canberra, sort of had like a very like rural type growing up. So I went off to college, studied maths, economics, and statistics. And so via the statistics route, that's how I came to love or came to find like a passion for machine learning. So after my undergrad, I decided I wanted to go off and do a PhD. So I went overseas, studied in the UK for 5 years, and yeah, just really sort of like rode this wave of like explosion of interests and progress in machine learning and deep learning from 2014 onward. So uh, that's sort of my the school part of my life. Then after school, I was looking for yeah, decided I wanted to go really like a industry route. So work on like applied problems, solve create like business value. Oh, it looks like
That's
Dan's just
okay. Just
and so I spent 2 years at Twitter as like a applied ML researcher, and then 1 year at Meta. And then had a great time there. Since then, I've been really getting up to speed on generative AI and did some consulting work, explored the world of startups, and now very excited to be part of Zillits as a developer advocate.
nice. So before we introduce Dan, I have another question for you, Stefan.
Yep.
So how do you differentiate between AI and Gen AI?
Yeah, sure. So great question. So I mean, I think they're both sort of maybe sort of like perceived as marketing terms by more research-oriented people, but I think I would describe it like this. So AI is the very high-level term that includes machine learning, but also forms of intelligence that don't involve machine learning. So things like planning algorithms and so on. I think generative AI, I would say it has to involve um, like a very high dimensional complex probability distribution. So for example, like a distribution over sentences or a distribution over speech signals. And as opposed to like maybe sort of like more classical machine learning that's really based on supervised learning, and the focus is like classifiers and regressors. So like modeling very low dimensional conditional distributions. So yeah, I think generative AI, I think it's as opposed to like AI more broadly, it's about these high dimensional probability distributions, sampling from them, using them for downstream tasks, transfer learning, and the fact that we've been able to scale them up has just really yeah, just sort of uh, made us able to build some incredible things. So it's a very exciting time.
So what's your current tech stack that you're using?
Yeah, so my current tech stack, so I'm a big proponent of open source. So firstly, PyTorch. I really love PyTorch. It's been so influential in not just like deep learning research. It's sort of like the dominant tool for researchers, but also in industry as well. It's becoming, I guess, sort of like taking over from TensorFlow as one of the dominant deep learning frameworks. So firstly, PyTorch, and then another thing I really love is the Hugging Face suite of libraries. And so that's like transformers, accelerate, bits and bytes, data sets. And I just think it's like, it just kind of like blows my mind how we can access so many free models, many of them with a commercial use license, models, data sets. And so, this sort of like really empowers the average, citizen engineer or like hobbyist. Um, and I think it's going to really drive innovation. So PyTorch, Hugging Face, and then I have NVIDIA graphics card at home.
Nice, very nice. So Dan, welcome. My
Welcome.
first
Thank-
question to you
thank you.
is, what do you think of Tim's outfit?
I love it. I love the Halloween. It's coming up around the corner. He's ready to bust some ghosts, right? So I'm a big fan.
So why don't you tell us, and everybody in the audience a little bit about you and your background?
Absolutely. So I've been doing computer vision for probably close to 7 to 8 years now. I've seen so many different sides and what computer vision can look like. I've been in the robotics field before. I've been in hardware. I've been in quantization was where I got my starts. And what was so cool about getting my start in quantization was pretty much every model can get quantized, right? So you end up seeing so many different customers, so many different models, so many different use cases. That really broadened my perspective of what is really being done right now in the field. Now I work with Voxel 51 as a machine learning engineer and developer relations, where I work with open source every day. I connect with other open source communities to kind of bring out, the best of us in the computer vision ecosystem to kind of push the further learnings, kind of build up the tools as the field grows, right? There's so much more demand for new things and new tools and new methods to be implemented and new models, new data sets, right? So trying to keep up with that curve and kind of educate everyone who is, trying to get into the field and experience that for the first time, making sure that they're getting what they need as well.
Yeah, I think that's very admirable, and very much needed. I think there's a lot of developers out there. I think some numbers that I've seen is there's over 200 million developers, but clearly not all of them
Yeah.
are very aware of all the details behind AI. So thank you so much for helping a lot of these people out. So I'm going to ask you the same question. So how do you differentiate between AI and Gen AI?
Yeah, I thought Paul made some great points, right? About AI is like the umbrella term here, right? Everything kind of falls under a lot of that for the most part, especially when you get to a marketing person. Pretty much anything can look like AI, right? As long as it runs some code in the background, right? But in terms of Gen AI, the way I think about it tends to be, we've spent so many years trying to pattern match in AI, right? Can I find the dog? Can I find the cat? Right? Kind of thing of pictures. Gen AI is this new turning point where we are now not pattern matching, but trying to create new patterns based on, different modalities, text or an image prompt or whatever it might be, right? Where no longer are we looking for the model to find something, we're now asking the model to create something, right? And that has been obviously very powerful in the field.
I love that. I think that's a really clear definition. Not like any definition is incorrect, but I thought that was really
Yeah.
nice. So what's your current tech stack?
Yeah, great question. I totally, like, once again, PyTorch has done wonders over the last couple of years. I mean, I can remember back to 2020, 2021 times. And I mean, that sounds like prehistoric ages, right? Nowadays, when we talk about this, right? The pre-ChatGPT days, where PyTorch was really starting to take off as this open source alternative to TensorFlow. We were still defining models like layer by layer. And, if your model didn't have a high enough accuracy, you just dropped another layer in and hope for the best. So PyTorch has been wonderful with all the different use cases that they support, and it just works, right? That's really what's most important for me as a machine learning engineer. I need stuff that always works the way I want, it installs easily on every machine, right? As someone who has worked with a lot of NVIDIA architectures, as mentioned, right? But also the smaller ones like Jetsons and Nanos and things like that. PyTorch being able to fit so nicely onto all these different machines is really helpful no matter what operating system or distribution, if you're ARM or x86, it's very powerful. On top of that, Hugging Face as well is great. I find a lot of my great data sets there, right? A lot of the big models like Meta Sapiens comes out. That's the first place I go to run it and check it out, right? And they're very dedicated to open source. And we actually, one of the main tech stacks I use all the time, of course, too, is 51, which is, the open source community that I make my content for, I partner with, and I work for, where I've been using 51 before I worked for 51, right? I thought it was an excellent opportunity to go and join the team and be part of that open source community where just visualizing your data sets is like a wonder to the field, right? And there's still so many engineers out there in the computer vision field who like haven't yet experienced what it's like to just like look at the data before you train it. We used to just throw a folder at the model and it's like, well, it's 75% accurate. Like I can't do anything else to it. I threw the folder at it. So being able to like clean and curate your data, evaluate your models all in one place, even just to get over the hump of like COCO versus YOLO data sets or COCO eval on a YOLO data set or something like that, which used to be the biggest headache to write for, you don't really have to worry about anymore. So I +1 to PyTorch and Hugging Face, use them probably every day, but also am using 51 every day.
So I'm going to ask three of you to describe one of the texts so our audience can really understand. Obviously, Dan, I want you to, talk about what is 51. And then, Stefan, I think it'd be great for you to describe a little more detail what PyTorch is. And then Tim, if you don't mind, describing what Hugging Face is. You guys are all very familiar with these three things, but for our audience, let's break it down. And not like how a marketing person would break it down, but like how you would, describe it to your best friend. So we'll start with you, Dan.
Yeah, totally. So 51, if you haven't heard of it, it's a open source Python library, which you can install very easily by just pip install 51. And really what you want to think about it is it's kind of like a data set debugger, right? And the best way to describe 51 is to describe this overall shift we're seeing in computer vision and AI in general, which is moving away from model-centric training, right, to more data-centric training, right? There's a reason why Meta releases Sapiens and Llama and all these great models and not the data set, right? It's because they clearly see that the value is in the data and not the model, right? They're open source first, they push these things out. And nowadays, if you are trying to build your own models, right, you're fighting a losing battle, right, where someone else is more likely going to make a better model than you. This isn't an ego thing. You need to swallow your pride, right? The real thing that you're the expert at is the data and the problem you're working on, right? You're not just doing your MS COCO 80 classes, right? You know exactly what the problem you're working with is. So what does that look like, right? How do you build better machine learning systems? It really starts by getting your data to be as high quality and managing that in a way which you can pull the right data off for the right task for each application you're building. And by doing that, that's really what 51 is designed for, right? It's a data set management tool, but it's also a data set debugger, right? So if you have any blurry images, dark images, if you need to find exactly where your model's doing the best, right? It's great if my model's 95% accurate, but if it doesn't slam on the brakes when the kid's ball goes in the street, then it's not good either, right? So being able to find these edge cases, these outliers, as well as being able to pull in all your favorite tools like Hugging Face, as we've mentioned, right? Model experiment tracking, whatever you need to kind of make sure that you're getting the right data for the right problem. That's all what 51's about.
So if you're a developer just getting into AI, it seems like you're actually at quite an advantage. You don't have to deal with creating models. I know like some people, that was really fun for them. But I mean, what you just described is a much easier entry point for developers. Maybe you can just touch on that a little bit. What do they actually need to do to get started?
Yeah, and especially in visual AI, as we're coining it nowadays, it's a visual problem, right? Like you should be able to see exactly what you're training your models on. You should be able to see what your augmentations look like, your diffusion models or what they're doing. You should see where your model's doing well and where it's doing bad, right? And so just being able to have tools and intuitive tools that are sliders and things like that to be able to find these parts of your data set where the model's not doing that well. That was a dog, it said it was a cat, that kind of stuff. Especially for people who are learning computer vision, maybe this is your first time trying to build your own model. Visualizing that does so much more for the educational experience than back in the day when we were just watching losses going down and accuracy going up, right? It doesn't really speak to what's happening on your data set.
Yeah, exactly. It's like you're the back of the house. You don't have any idea what's going on.
Just black box, I hope it does well.
So, Stefan, what's PyTorch?
Yeah, great question. And so, just before we get onto that, so just on your point of how does like someone sort of new to AI get started, I think it's just like really incredible with Hugging Face and other libraries how quickly you can take a pre-trained model and build some sort of application. So for example, imagine you're like a video game programmer and you want to add speech recognition. Then with a few lines, you've got OpenAI's Whisper model. Just imagine that you're doing a website and you want to do say like face tracking from a webcam. Again, pre-trained model from Google, a few lines of code, and then you have like a state-of-the-art system going. So I think that's something that's definitely like a change from even a couple of years ago, just like the wealth and variety of really high quality state-of-the-art open source models. So talking about PyTorch. So PyTorch is a Python framework for essentially doing deep learning. So building neural networks, implementing them on hardware, also has some libraries for serving and productionization. And interesting how Dan mentioned that he can remember when PyTorch first came out. It doesn't seem that long ago to me when TensorFlow actually came out. So as a PhD student at the time, I was using this library called Theano. And it was just like the very early stages. And then, this newfangled thing, TensorFlow, came out. But very quickly, my PhD colleagues were switching to PyTorch. And let me just try and explain like what was different about PyTorch at the time than, say, TensorFlow. So imagine you want to build a deep neural network using Python, using some framework. The way TensorFlow works is, or TensorFlow version 1, you would have like a declarative paradigm where you would create a computational graph of the neural network, saying like what the operations were, how the input goes through all the functions to the output. And then you would call a function to, in a sense, compile that graph and run it. And so that, that sort of like works okay. It's good for optimization because you can sort of like defer the computation to when you compile the graph, but it's very, very hard for debugging because you're no longer sort of in the middle of a Python program. You're in this sort of like pre-compiled graph. So when PyTorch came along, it had this really fantastic idea that we could simultaneously create the model just with like regular sort of imperative style Python code, but at the same time construct the graph that you would need for doing back propagation through the model and learning it. And so you could debug your model, and as it was just like regular Python code, you could set a breakpoint here. Everything was much more transparent. And then that just became the dominant paradigm. TensorFlow 2 implemented a version of that to try and catch up. So yeah, PyTorch, it's a deep learning framework that sort of had this revolutionary sort of like paradigm of doing your model. And yeah, just sort of took the research world by storm. It's still the dominant tool for publications, but it's also very, very widely spread within the industry as well.
Nice. All right, Tim, how would you describe Hugging Face? Because I feel like Hugging Face has many faces. It does many things.
Hugging Face is perhaps I don't know if I want to say the greatest thing to happen to machine learning, deep learning, and Gen AI since PyTorch, but I mean, you have something that's open source, free. It's to me, it's the mega GitHub of everything model. I mean, you've got a collaborative community, open source for machine learning, natural language processing, deep learning, AI, where you could build, train, deploy models. The community there is awesome. There's leaderboards, there's interaction, all the things you want from, online community with none of the negative or bad things. Awesome data sets, which, if you have a big enough program, almost anyone is downloading some data set from there. So great place to put the big weights and data sets you need. And one that I use perhaps every single day their Transformers Python library, which, you know, to get and train models and to use them for embedding almost every day. We have a bunch of good models we use from there. It is great. I mean, if I don't go there every day, something's wrong, or I'm traveling, or something's going on. If Hugging Face goes down, that's key infrastructure for me. I mean,
I feel like it's the Costco for ML, right? It's got
imagine
everything
if
you think of.
Costco was everywhere, faster, easier, but free. I mean, you like, to me, it's great. I mean, for me, it was a great place to start discovering models. And before I had a place to run them, they have a lot of the smaller models that you can call with inference through a REST endpoint. So it didn't even need to have Pythons installed anywhere that could make a REST call. So helpful. It's
Yeah.
that's if that's not my favorite place to hang out besides the Milvus Discord, I don't know where else is. Maybe I don't know,
So,
maybe
Dan,
fighting these ghosts, but if you are not on Hugging Face, get an account, start using it. And if you get if you need to run some of their inference endpoints, you pay like 30 cents or 3 cents or something. So it's great. It's great.
So Dan, for a new developer coming to Hugging Face, it can be like a little overwhelming. I mean, there are so many models, there's so many characteristics that they can consider, there's so many data sets. What's your recommendation? Like, what should they do first? Instead of just like the obvious, which is, oh, just pick the model at the top.
Yeah, great question, right? And I always tell people, like, forego like maybe any traditional way that you want to learn a new topic, right? Set out with like a cool idea that you wanted to do, right? Maybe hook up your camera to it, or hook up your PDF doc, or whatever you want to do, depending if you're going to go text or computer vision, right? And just decide, like, what do you want to do? Do you want to create a camera in your backyard that lets you know that there's squirrels there or something like that, right? Like, do you want to have someone that reads out your calendar every day? Like, whatever it is, right? Just set out with that goal, and then don't learn any of the foundational math. Like, don't worry about it. Like, learn the Python if you know Python, if my friends are developers and such. Like, grab the model. I'm sure there's so many great Medium articles out there that will point to Hugging Face data sets and models and such like that. You don't need to train a model your first go around. You might not have the resources to train the model the first round. But like, probably anyone that's familiar with Python, as we've mentioned, in 10 lines or less, can kind of build out these applications where your webcam opens up and you hold up a picture of a squirrel, and there, it finds the squirrels there or something like that, right? And so set out with a goal in mind, kind of get the machine learning ML experience there for you, and try your best to do that. Because if you're chasing a passion of a project that you want to do, or a cool problem that you think is awesome, that's what's going to drive you. If you get so bogged down about, well, do you really know the difference between instance segmentation and semantic segmentation? Like, you're going to get lost in the sauce. Don't worry about it. Have fun with it. It should be fun. And if you think it's fun, then if you want to continue down this path, then you can actually start to take a couple steps back and, build your way up. But for that first initial project, just have fun with it. Look up some cool idea. There's so many resources on Hugging Face, as well as many other websites. Medium has great tutorials on how to your first models kind of stuff, where you don't really have to dive too deep. So if you're concerned that you're not smart enough, or it's going to be too complicated for you, let this be the voice to tell you that that's not the case. If you can write 10 lines of Python, then you can figure it out.
I love that. I love that. Why not look for the squirrels in your backyard? And then, I'm sure after you have success with that in just not a lot of time, then you're going to just keep building on it. And by the time, if this is a weekend project, by Monday, you're going to have something pretty impressive.
Yeah, exactly.
So anyone can answer this one. In fact, I encourage all of you guys, and maybe we can just even talk about the answer in more detail. So what new tool or model did you learn about this week? Because let's face it, this space, something's coming out every second. So let's start with you, Dan.
The coolest thing I saw this week so far has been Pyramid Flow, which came out. This is a open source text to video model. It's very fresh. So if you want to try to run it, you're probably going to have some difficulties. You're going to have to install their GitHub repo, and a whole myriad of things might happen to that. If you wait a week or two, I'm sure it'll be in a nicer package on Hugging Face or wherever you get your models, Replicate, things like that for model serving if you have GPU issues. But Pyramid Flow is a open source project. And what made it so great is if you watch the open source community or the closed source community for that of video generation over the last year, especially even the last 6 months, it's like not good, right? It was very bad. You would maybe pass a first image in and then just like for 2 seconds slowly corrupts the image over time. You're like, it's a video. And you're like, is it? You just kind of made it blurry, right? Or it moved around, or I gave a picture of a corgi and now the corgi is just like smiling now or something like that. Like there was not a lot of dynamic movement going on. The FPS was really low and the quality was really bad. Pyramid Flow, in an open source approach, has smashed previous open source length of videos from previously only being like 16, 20 frames to now we can have 10-second long clips of 24 FPS at 720p. And if you go and check out the GitHub, it's really impressive the results they're able to do. It's not perfect. It's still got that Gen AI funk on it, right? Where it looks a little sketchy every now and again. But what a large step forward in terms of where we would hope to be, right? Some of these clips, they're getting really close to like, hey, if this was like in a movie, like I wouldn't know that this was Gen AI. And if you're, a small budget movie maker, or you're doing class projects, or maybe you're just running, D&D games with your friends, right? And you just want to have these cool generated clips that you're creating. What a step forward for especially the open source community, as video has been some of the more closed source, part of computer vision for the last year or two. What a win for both the academic research as well as the open source community with Pyramid Flow.
And a win for Christmas, because remember like 5 or 6 years ago, we all made those stupid dancing elf videos.
Yes, absolutely.
It's going to be so much better now. All right, who wants to answer next? What cool thing did you find?
Yeah, can I take this one?
Yeah.
So one cool thing that I found about this week was the latest release of this library called Outlines for doing generative AI. And so Outlines, it's a library that allows you to sample from your large language, also to generate from your large language model when you want a specific format. Perhaps you want to output XML, maybe you want to output like a programming language. You could even just maybe like want to output like a category if you're building a classifier. And so this is a library that's come out like official version this week, and really effectively allows you to build this into your pipelines. So yeah, encourage everyone to check it out.
Nice. Tim, what did you learn this week?
There's a bunch of stuff. That's why we got to do this newsletter. Well, the new hot sauce, contextual document embeddings, CDE, it just popped out again. Hugging Face trending. You find cool stuff. It's got some interesting feature extraction. It's starting to take a look at it. I haven't got to try it yet because it doesn't seem to apply to Ghost. So that one I might not need today. And then I've been looking at some of the clip stuff. So there's a new one from Xtuner, Lava 5.3 Mini, which is one of the Lava models. It's fine-tuned on a combination of Clip and Microsoft 5.3. So it's not too huge of a model, but it should do some interesting stuff on something that could take text and image to do a search, which I'm already using one of our standard Clip models for the Ghost searching, because I want to be able to search Ghost any possible way. So whether you type some text or you pass in a picture, figuring we use Milvus to do the ghost detection. and analysis of ghosts. But yeah, there's awesome models. By Monday, there's probably a couple dropping today. It's like there's some new ones. If you don't watch, again, Hugging Face, watch Hugging Face trending, and you'll see cool, interesting projects always.
So I think we know what you're building now, Tim, for Halloween. So I'm wondering, oh, he's gonna bring it out.
So it's so there'll be a Raspberry Pi in here to suck in a ghost. I got a camera set up that captures spectral images. We transfer that into Milvus. If it's detects it that it's a ghost. If it's not a ghost, we'll let it out of the trap. If it is, goes in the trap, then we have it stored so you could search and go through all the ghosts. No need to worry about any kind of nuclear breakdown.
So Dan, how can we use Pyramid Flow for this trap?
Yeah, you can probably help, expand Tim's fantasies over here by generating him maybe catching some ghosts or so. I'm sure that would make him very happy.
Not a bad idea. We'll make a whole movie.
Cool. So what is new that's happening with Voxel or 51, Dan, that we should all start studying up on? Besides our little project that we're going to work on for the weekend, where we're not going to think about, overthink things. What should be the next step that we can maybe turn to 51 to expand our learning?
Yeah, we've spent so much time over the last half a year really focusing on the education portions of things. One of our developer relations members, Harpreet, just released a data-centric visual AI Coursera course. It's like 10 hours long. It's got tons of notebooks in it. So if you are interested in starting for your first time, or maybe you just want to refresh on some of the more advanced topics, that Coursera course is now available. It's out. You just go on Coursera and check it out. It's super cool. But now, shifting away from education, we're not stopping any of these things. So we're doing hackathons. I'm doing a hackathon in New York City at the end of the month on October 27th, as well as a couple world tours as we're going to Europe and things like that to talk about computer vision, teach some workshops and such like that. What really excites me about what's coming up for Voxel 51 and what we're doing right now is, we keep on going to these conferences. We're meeting with our users, and we're just learning more and more that visual AI data sets are coming in all shapes and sizes, right? We used to have an image data set and a video data set, or, maybe you're working with 3D assets. But so many people are doing these awesome projects that include, a camera feed, and that camera feed's a video, but that video feed is being blown up into 3D, and that 3D is getting into a 3D mesh, or, all these different avenues of inputs and outputs in different shapes and sizes. So being able to build these data sets in a way that is much more intuitive for you to work with. We have this big scene right now for things like 3D reconstruction, right, which is really dependent on multiple models happening. So being able to track these models at each step of the way, whether it's something for self-driving, maybe it's just AR, VR use case or some other things. I'm excited to see all the advancements in that way and how 51 is built for these kind of use cases, right? Shaping to whatever problem you're having and being able to give you the best quality data set and experience along the way.
3D ghosts, Tim.
I heard things and my mom is going, this project's not going to end by the 31st. I mean, I loved when you guys came out for our meetup. I mean, it was really popular. I mean, it's just awesome UI, awesome libraries. Again, in that toolbox of really cool stuff, which expands daily.
Yeah, we have a really good ecosystem, and really talented engineers who, since we're open source first, that's not changing anytime soon. We've built so many awesome internal features where we're like, wow, we should just make this way easier to build and for anyone to do, right? Let's expose all the tools that we're using internally to help build new features into 51. So now, you can code all these custom UI journeys, whether you want custom evaluation panels, if you just want a UI to walk you through your model training path or your model cleaning process For education, you can pull up a YouTube video while you work on your data set to see what you should be looking for in your data sets and such. All of that is completely exposed, and all that UI is all Python. We've done the dirty work of connecting the JavaScript to the Python. You just have to write a couple Python lines, and you'll get access all to the pretty JavaScript buttons and clicks and events and things like that. You don't have to get hands dirty if you're not a fan of JavaScript.
Tim and Stefan, what question? Let's have you ask Dan some questions.
Tim, do you want
I had one up, but you can go if you want. I get that.
to? Yeah, geez,
I'll ask one of our.
putting me on the spot there. I'm kind of like stumped.
I have one. I can ask you a question because I'm
One
curious if
that's
you had a
great
chance
moment.
to look yet. Have you taken a look at the GraphRag from Microsoft, or just your thoughts on GraphRag in general?
Yeah. So great question. So yes. So yeah, I mean, I think this is like a really great direction. So looking at, I mean, the basic idea of RAG is very simple. Have this database that you can look up and then introduces your context into your large language model query. So you can give it facts, examples. So I think, yeah, sort of like definitely the next step, looking at information in different types of formats, whether that's like a knowledge graph or it could even be like a relational database. So another sort of like maybe like sort of related idea is making your RAG system produce a query to query your relational database and then get back the relevant information from that. So yeah, so I think it's a very sort of important and natural development, and I think it's going to become like a standard sort of component of like the how we do RAG.
Yeah,
I
that's
think
interesting.
I think the relationships between entities really does matter, and I think it's really opened, I think, a lot of people's eyes to, like, trying to bring that relevant contextual data requires much more than just storing the data as vector embeddings. It also opened my mind to that. Maybe there's even more things that we have to think about to bring that kind of relevancy to the table. I feel like this is just kind of the beginning.
Yeah, I also feel the same way. I've seen it heating up from my seat, which is rare for me because I rarely go into the LLM space too deep, right? VLMs and anything that crosses over, I'm familiar with. But there's a lot of interesting work coming out with the GraphRag, and we have even people that are doing image work, computer vision work, and using GraphRag, and they found out that it's better to just generate captions on your images and then use that for your GraphRag and everything like that, instead of using like a clip model or something like that, because the state of it is that we're way better at generating a prompt for a picture, and then all these systems have been built for prompts, so it's just way better right now. So it's bittersweet, right? Like, it's nice to know that we have these really powerful systems. It's kind of stinks that they're not that great for vision yet, right? That we haven't gotten to that cross that bridge yet, as I have the nice bridge in my background. I hope to, I love it now. I can't wait to see what it's going to become, right? It's really what I'm trying to say.
So Stefan and I both live in the land of what I like to call robot taxis. So we live in San Francisco, where, like, sometimes the Waymo taxis outnumber the cars. And I bring that up because, to me, like, that's the first like use case I think of when it comes to computer vision, is like, making sure those robots are not going to like run me over. And then the second, use case I think of for computer vision is like ensuring like quality of like a machine output, like in a factory, or like, how about the apple that the machine picked, making sure there's no worms in it. But those feel kind of like, I don't know, old school. What are like some of the super interesting use cases that are coming out of computer vision, Dan, that hopefully can inspire all of us?
That is a great question. some of the stuff, you know, if you're following the trends, right? I've been trying to put, I talk about this often whenever I go to my talks and stuff like that. And I challenge the audience to say, like, you need to pause and think in the grand scheme of things. Like, what does this paper I'm reading mean, right? Is it just a cool paper that's kind of state of the art now? Like, you know, like, take a breath. Like, what does this mean for a year or two moving forward, right? And I think we're kind of in this period right now where we have so many academic papers coming out that are really going to serve to be more like the wheels of the car coming out in the future, right? Like we don't have the engine yet. We're waiting on the engine. We know the engine is going to come, right, with more GPUs and more research. But what can we do, especially in computer vision, to keep on building these wheels, right, for everyone that is going to connect these large agents, these large models that are going to come in the future? How can we, from computer vision field, give these models the best information to inference on and things like that? So to put it in an exciting way, you know, if you're excited for things like AR and VR, I mean, it's absolutely getting blown through the roof right now. Have we seen it all put together under one roof yet? No. But is that a year away, 2 years away? Maybe, right? Meta's coming out with their glasses now, and you can see the models and the papers that Meta's putting out where they're able to completely segment a human body. I know exactly what clothes you're wearing. I know the difference between your left arm and your right arm and your elbows and all these kind of things. So we're not that far away from things like sitting in your kitchen and having a menu pull up in front of you, and you're cutting your food and the camera tells you you're cutting too finely, and, you know, you added too much salt, or, you know, don't forget the knife is behind you, right? Or any of these kind of things that are going to be available through the AR and VR glasses. And then even moving forward, right? Just being able to empower these robotic systems of the future, right? Where we're going to have these people interacting with us on a daily basis, right? Whether it's at a checkout line, or if it's the person working on your car, or whatever it might be. If this person is going to be a robot in the future, how can we empower these systems to give them enough context to see, like, oh, like I said something and that made him upset, right? His face drops, things like that, or I'm standing too close to him, right? We don't want to have any of these awkward, uncomfy, we don't want to get stuck in the uncanny valley. How can we kind of come back over the top here? And the answer is going to be through very unsexy computer vision happening in the background, right? There might be a really great model from OpenAI or Meta, whoever was the one that comes out with it, but they will be absolutely working off of computer vision systems as the inputs.
When you were talking, I realized that I had an experience with a Waymo car yesterday. And, I thought I had the right of way to turn. And as a human, I looked at the Waymo as if I was looking at a human, and I almost like flipped it off, right? I was angry. My face was like annoyed. But why shouldn't that car take that as an input, right? And react to it.
Absolutely, right. And I think that's kind of where we're heading towards, is bridging this gap, right? I don't think for anyone that's worried about Terminators or anything like that, that's not the road we're getting towards, right? It's more about how can we make it the most responsive, where everyone feels safe with it, right? No one's going to want to adopt this technology if it's a self-driving car, if it's a robot working for you, or whatever it's going to be in the future. AR, VR glasses are even another great example. If you don't feel safe, if it doesn't feel comfortable, if it's not reacting to you as a way that you would want any other person or system or person to treat you, then you're not going to use it, right? So we have to make sure that we're being safe, that these models are highly accurate, but that also includes potentially flipping it off. It should take that in as well. Right?
I mean, also, I was thinking, in Japan, they just don't have enough people to do kind of like the general jobs, right? So a lot of restaurants over there are starting to adopt robots. But I can just imagine, I have this crazy vision in my head where, like, you're at a ramen bar and it's too hot, the robot's gonna react, right? Or it's too spicy or whatever, and they can, oh, here, I'm so sorry. Yeah, we gotta, and this is all probably gonna happen really quickly.
Yeah, well, I've heard about factory robots that actually sort of, like try and read the expression on someone's face, or like see where they're looking and then react to that. So I think, yeah, definitely sort of seeing like the initial initial cases of that.
And maybe here's a really funny one. So anybody from Waymo, you can pick this one up. What I see in San Francisco all the time is I see all these visitors who get their Waymo car, their ride, And then at the end, they take a picture with the car. But it would be hilarious if somehow, like, you know, when right as the picture is about to be taken, that the car like flashes a light as if it's like, you know, posing with them.
Yeah, it puts a little smiley face up or something.
Put the smiley face up, because on the top of it, they have a little rotating light, and it indicates like, are they picking someone up? Are they, you know, doing something? So they might as well just have like a little smiley face. That just gives it that
Yeah.
whole human experience. Okay, so we're almost at the top of the hour. So we have a couple of questions for you, Dan, to bring us to close us out. So what do you think AI is going to look like in 5 years?
Ooh, what a tough question, right? Man, I think it is going to become very segmented, right? I think there's going to be a like people are going to want to move towards this embodied AI use case, right? Where vision and language and everything blends together. We're going to head towards that. And that nucleus, I think, is going to happen before 5 years, right? What happens after that is then, do you have 1,000 GPUs to throw at this problem, or do you not, right? And how do other users adapt in this world, right? I think the correct answer will be that we're going to have these power farms of GPUs from big companies like Meta or Microsoft and OpenAI and things like that, who are pushing out the ChatGPTs, the Lavas, the Llamas, whatever they are of the future. And then it's going to be on us as the developer ecosystems around these to then build and adapt with these tools, right? It's no different than how we use Copilot today. I don't think it's doom and gloom, and I don't think it's going to be anywhere close to a general AI or anything like that in 5 years, right? I think anything that's going to be practical for that will be further down the line, but it's going to be, you need to start thinking about how you'll shift your systems to be grabbing models, like I said, and building the best applications for them, right? You might be grabbing a portion of this model. You're going to be renting out a little bit of GPU time from this mega cluster somewhere, whatever it might be. This is what the world's going to look like in the future. So being able to have things to like address the problem you're dealing with, right? So maybe OpenAI, their job is to address every problem, right? But your job is to count fish in the Atlantic Ocean, right? Like, how can you then take this application and then build it so it counts the fish in the Atlantic Ocean the best it possibly can, right? It doesn't need to drive me there. It doesn't need to, do any specific use cases here, right? But it's going to be much more focused on the tools and the applications and move away completely from the model side, right? I think model building will be a thing of the past, right? I don't know how you can compete, right? I think you can have great architectures ideas, right? We look at like the CAN graphs. Sorry if I don't remember the full word, but people trying to move away from traditional CNNs. We moved from CNNs to LSTMs. That was great, and then we moved to attention. That was great. So we would hopefully see continue of this math. Diffusion math has been awesome. I know it's not as cool named as some of the other things, but what we've learned about diffusion networks and how we can train our models, that will continue. But if you're trying to come out with state-of-the-art models in 5 years, you will not be able to do it unless you're one of the big 4 or 5 companies that has, whatever it's going to be, like 80% of the world's GPUs, right? So that's kind of how I envision it, at least.
I love that. Power farms. I think Tim's trying to build a power farm in his little office. He's got 1 million devices.
Yeah.
So my last question.
It's self-aware over there.
My last question to you and to anybody, but you put quite a bit of emphasis on open source. So close us out with like why open source matters.
That's a great question, right? It matters for a lot of reasons, right? And the main reason, I'll answer this in 2 ways, right? One is for the newcomers, right? If you're not you don't know where to start, right? You can't afford to build all these tools yourself. You don't have the staffing to build these tools yourself, right? And I've been fortunate enough to interact with people in the open source community where if you're starting your own startup, I can't think of a better place, right? Building on these tools, they're going to continuously get it better. You can feed back and they're going to give twice as much, if not more, back to you, right? And so building up this ecosystem where everyone's helping out each other, everyone's trying to help each other out, you'll get way more success as a hobbyist, as an engineer at their job, as someone starting their startup. you're basically expanding your team of engineers to thousands, if not hundreds of thousands across the world to be on your team, right? And help you out. And it's really just the best community and everything like that, in terms of, building you up. And so I can't say enough about the educational portion, how kind everyone is there. But if you're looking at this from just a strategic standpoint too, right? Because we have to address that as well here. Because the number one thing, especially if you explain to someone that's not familiar with tech or coding, they're like, open source, you just made all your stuff free. Like, why would you do that? You're not going to make any money off of it, right? The truth is, and you can look at a company like Meta, right, as a great example. Look at the TensorFlow versus PyTorch debate, right? Look at Llama and all these other models that are coming out. If you build open source and you're now a leader in the open source field, this shouldn't be your sign. I see this all the time. It drives me nuts that if you become a leader in the open source field, then you close source your stuff to make all the money. Like, it blows my brain. You're imploding your company, right? You look at companies like Hugging Face, like they haven't stopped. They're not showing any signs of being weakness. Look at their latest evaluation, right? I don't think they regret making all their stuff free, right? And the thing I'm getting at here is, if you open source your code and then all of a sudden you're the leader in the space and continue to open source your code, that means that everyone's building with you. That means that everyone is in your ecosystem and everyone is adopting your standards, and that you have the power to say, I want to make this right. Like, I want to make sure that everything's going the best way. I want to make sure that things are clear and clarity. There's explainability, that everyone's safe. They understand what's going to happen, right? And you get to set those guidelines of what that can look like. You get the influence of other people in your open source community to come help you out. You make all these great connections. There's no excuse for, you look at Meta, you look at Hugging Face, there's no point where you stop being open source, right? You always be open source, and that will only keep on paying dividends back to you over and over and over again, right?
Yeah, no need to push the panic button just because you're widely successful on open source.
Absolutely.
You just have to think a little bit differently on how you can monetize. So just keep the projects open, and then there's always something you can provide as a support to open source that people are feel really comfortable paying for it, right?
Yeah, there's always going to be real pain points. There's going to be other pain points that if you're really worried about monetizing and building a company, we all have to pay bills, right? The real problems to solve are usually not in the open source, right? There's other ways to adapt this, right? Hugging Face serves GPUs, right? For instance, right? This is one of the ways they make money. They make money other ways, of course, but this is a real pain point where people don't have GPU access, things like that. 51, for instance, completely open source, right? I give you 100% of the ML tools. There's no caps on the space there. You can load as big of a data set as your computer can handle, right? But there's real pain points on things like cloud-backed security and permissioning and dataset versioning and all these other things that we just don't really see like an academic research have pains with, right? So, we can find our own niche and things like that. And open source companies change over time, and where you make your money and where you're monetizing might change. But what should never change is the fact that you're open source first. You're pushing that community forward. If you're savvy enough, you'll figure it out, right? Like if people are in your ecosystem, that will always be a profitable way, whatever that profit is, money or learnings or whatever it might be, right? So there's really like no downside when it comes to just having a ton of people using your tool, right?
Yeah, plus your community will just tell you. If you're really, if you're really in the community, they'll make it really clear to you. Like, we love this thing. Can you help us with this? We'll pay you, for that thing. So the answers are like right there. It's not even that hard. Cool. Well, it was a pleasure hanging out with you. And we'd love for you to come back, and maybe we can like dig in a little deeper on computer vision, because I think it's really an exciting field. It's much more fun than talking about RAG.
I can show nice pictures next time, right? We can make a visual experience.
Well, maybe
Image
next
RAG
time,
is
Tim,
good.
you'll have the Ghostbuster or the whatever, that trap thing.
Yeah.
And
Awesome.
nothing
Thanks so much for
copyrighted,
having me
nothing
too.
copyrighted.
Awesome. All right. Thanks, everybody. Have a great Friday, and we can't wait to see
Enjoy
what
your
you build on
weekends.
the weekend.
Very
You too.
cool.
All right, thank you, everyone.
And thanks, Chris.